Hey everyone, today we're going to talk about solving polynomials, and there's two ways to do this. Today we're going to talk about the easier way, solving polynomials by factoring. Given a polynomial in that form, find the zeros. Well, this is really easy. X equals 0, x equals 1, x equals -3 with a multiplicity of 2, and x equals 7/3. That was really easy. This is an easy section, huh? Why was this easy? Well, it's easy because the problem was factored. So if we can factor these things with the way we learned last time, with the perfect cubes or the higher order quadratics or grouping, then this is a pretty easy answer. So we just need to be able to factor. So let's try one example of each of these problems, but first let's talk about it. We have to make sure that the polynomial is equal to 0. Then we factor as completely as possible. And we might have to factor more than just once. Set each factor equal to 0 and solve. Sometimes you have to solve the quadratics with square roots, or sometimes you have to use the quadratic formula. And remember, the number of zeros must be equal to the degree of the polynomial. If you have x to the 4th, there has to be 4 answers. Let's start off easy. Sorry. X cubed plus 64 equals 0. Well, it's equal to 0, so that's good. Let's factor it. Perfect cubes. Take the cube root, square the first, multiply together and change the signs, and square the last. So now that I'm factored, let's solve. This is x equals -4. That's easy. This one is not as easy. This won't factor. So how do I solve a quadratic that won't factor? I have to use quadratic formula. Opposite of b plus or minus square root of b squared minus 4ac all divided by 2a. Now let's clean it up. That's 16 minus 64 is -48 all over 2. Well, give me two numbers that will multiply to 48, and one of them is a perfect square. 16 and 3. So I get x equals 4 plus or minus. The 16 comes out as a 4. The 3 is still on the inside. But wait, it's negative. How do I bring the negative out of the square root? Make it I, all divided by 2. If you give me that answer, you lose points. What do you see that everything on the outside can do? I can divide 2 plus or minus 2i square roots of 3. Now let's stop and see how many answers we have. I have 2 answers here, 2 plus 2i squared of 3, 2 minus 2i squared of 3, and I have 1 answer here. So I have a total of 3 answers. That's how many answers I needed. Little question for you. If you have a third degree, what are the possibilities for your answers? Well, all 3 of them could be real, or you could have 1 real and 2 imaginary. Why can't I have 2 real and 1 imaginary? Because imaginary answers have to come in pairs. And because these are 2 answers, I can only have 1. I can't have 0 real and 3 imaginary because I'd have 2 that were together and I'd have 1 left over. So I either have 3 real or 1 real and 2 imaginary. Let's try this one. What type of factoring problem is this? This is a higher order quadratic. How do I know? Because this term is twice as big as that term. Let's factor it. I need 2 numbers that will multiply to -20, but add to +1. That's 5 and -4. It's not just going to be plain x, it's going to be x squared and x squared to match the middle term. Can I factor any further? I sure can. This one won't. This one will. X plus 2 and x minus 2. These are easy. This is x equals positive 2 and x equals negative 2. But over here, I have to solve this. X squared plus 5 is equal to 0. X squared equals negative 5. Take the square root of both sides, and I get plus or minus, because I took the square root of both sides, square root of negative 5. But never leave an answer square root of negative 5. The negative is going to come out as an I square root of positive 5. So how many answers did I have? 1, 2, 3, 4. How many answers did I need? 4. So that one works. Notice that we're getting imaginary answers, but that's okay. For a fourth degree, what are my possibilities? Well, all 4 could be real. Or I could have 2 real and 2 imaginary. Or I could have no real and 4 imaginary. Why can't I have 3 real and 1 imaginary? Because imaginary answers have to come in pairs. I can't have 1 real and 3 imaginary because these two pair up, but this one doesn't. Okay, a little bit tougher. This one's not equal to 0. Let's make it equal 0. Four terms. What type of factoring should I look at? I'm going to do grouping. What does the first two have in common? An x squared. That leaves me at 2x minus 3. Be careful here. What number will divide both of those? And I know it's going to be negative. What number will divide both of those? 16 will. Divide negative 32 by negative 16, you get 2x. Divide 48 by negative 16, you get negative 3. Do those insides match? They sure do. X squared minus 16, 2x minus 3. Can I factor any further? Yeah. The x squared minus 16 will factor into x minus 4, x plus 4, 2x minus 3. But those are the factors. I didn't ask for the factors. I asked for the zeros. X equals 4, x equals negative 4, x equals positive 3 divided by 2. I have 3 answers. They're all real, so that's okay. I needed 3 answers. So this one works. That does it for solving by factoring. Just factor and then solve each of your little problems. Next time we're going to talk about what happens when you can't factor a polynomial. So stick around. Thanks everyone.